Hi, everyone. Welcome to your learning. Thank you for showing up for it. We are going to be looking at these two fascinating dots and what the heck they have to do with anything and why you might care about them. Why are you going around seemingly in a circle? What do those two dots have to do with that circle? You just keep going around and around on this circle. What do the dots mean? There you go, around and around in this circle. Well, what if I told you? What if I told you that you were on a Ferris wheel and that those 2 points model your vertical displacement as you go around the Ferris wheel and your horizontal position as you go around the Ferris wheel? How could we model such a thing with a mathematical function? You were going around the unit circle the whole time. And your vertical displacement traces a sine wave through the xy plane as you go up and down. And your horizontal displacement traces a cosine, this time upwards through the y-axis. And what if I told you that I spent altogether too long staring at this and actually feel like I learned something about trigonometry as I did? So, yeah, these are sine waves, cosine waves, and they're doing freaky stuff. How do we generate that freaky stuff? Well, you could take a look at my graph here. Here's the Ferris wheel picture, and it goes around and around in circles. And I told it to move around at angle A as A progresses, and I set up a slider for A from 0 to 360 degrees, and then I told it to go continuously in one direction. I can show you how to do these things if you like, and if people want to create something like this as a kind of choice board assignment, I'd be more than happy to take a look at what freaky things you can get Desmos doing. But anyway, there's just I modified these sine waves a little bit. Let's take a look at this one, for example. So we'll turn those ones off, and I'll turn all that busyness off. Let's not look at that or that or that. But here you are going around the Ferris wheel, and this sine wave here, the reason it's not flat, it doesn't have a constant amplitude, is because I multiplied it. Instead of multiplying by a constant a, I multiplied by a quadratic here. So this quadratic is about 1 at the end, and it's a little smaller than 1 in the middle because it goes down, nearly touches the x-axis, and comes back up. This is the quadratic here, 1 over 7.5x minus 2.25. So its vertex is over here at 2.25, halfway along that. So that's how I got to do some of this quirky stuff. And then, but how did I get the sine wave to do this, I wonder? Well, if you take a look at it, all that's changing about that sine wave is its phase shift is just going that way constantly. And in here, if you take a look, you'll notice that that slider D that's just constantly playing is just adding on to their x plus D, just all the way through. So that's how I got it to do that. Okay, so anyway, just some different ideas for you as you're playing around in Desmos. So we're going to cover these Ferris wheel type problems a lot today. So get ready and strap in and stay tuned for your learning. Thank you for showing up.